So last class we were talking about finding the x and y intercepts. We learned that if we wanted to find the x-intercept, we had to make y equal to 0. You plug that into the equation and then you solve for x. One of the main points behind this is that you want to know where the line hits the x-axis. Where the line hits the x-axis has to have the coordinates x and then 0. Otherwise, you're not on the x-axis at all. Similar with the y-intercept. If you wanted to find the y-intercept, you need to force x to be equal to 0. So you plug in a 0 for x, you substitute 0 in for x, and then you solve for y. That ordered pair would represent the y-intercept. So just to show you, let's go to my notes. And here's that quick recap. Problem number 4 was a great example to kind of illustrate how you find the x and the y intercepts. So the first one, you ensure that y is equal to 0, you plug it in and you solve, and that gave us that x is equal to -1.5. In order to find the y-intercept, we plugged in a 0 for x, and then we did the math and we found that y is equal to -2, okay? Once you have your two intercepts, you plot the points on your grid, and then you continue from there. All right, beautiful. So let's talk about graphing horizontal and vertical lines. So for this first line here, our horizontal line, I want us to notice these 3 points that I've plotted on this line, and I kind of want to have a discussion about it so we know what's happening. So for instance, my point here, the one that I'm looking at, so this point here has the ordered pair 2, 2. The point here on the actual y-axis, or our y-intercept, has the ordered pair 0, 2. Remember x, then y. And lastly, my point that's kind of like in front of all of the rest of these, that has an ordered pair of -4, 2. One of the things that I want you to be noticing, I want you to notice about all of these points, is that the y value was the same. The y coordinate is the same in every single point. -4, 2, 0, 2, 2, 2. The y coordinate is the same. So if we say it a little bit differently, we notice that y is 2. So the equation of this line is simply y is equal to 2. Not bad, right? So I want to do the same thing for my second graph. And this time, I want to look at these 3 points once more. Okay? So we have our point at the top, and we see that that is, let's see, -1, -2, -3, -4, -5, 2. So my top point is -5, 2. The point on the line, the x-intercept, is -5, 0. And lastly, this point is a -5, -1, 2, 3, 4, 5, 6, -5, -6. If we use the same line of thinking that we did for our first graph, we notice that with each of these points, the x value remains exactly the same. The x is -5. So the equation of this line is x equals -5. It's as simple as that, okay? When we talk about the equation of a line, we have many different forms. We had standard form, we had slope-intercept form, but we also have horizontal and vertical lines with equations specific to their type of line. So I don't want you to forget about these guys. When you think of y is equal to a number, I want you to think of a horizontal line. And when you think of x is equal to a number, I want you to think of a vertical line. All right, guys? Let's turn the page and continue. As a note at the very top, notice it says every horizontal line is of the form y is equal to b, where b is any real number. Every vertical line of the form x is equal to a, where a is any real number. So consider these 2 pieces of information. Don't forget them. Okay? Beautiful. So we're going to take a look at this in action. And again, I apologize. It seems like the live chat is not working. Let's see here. But I do see that you guys are watching. So I apologize that the live chat doesn't seem to be working for you guys. And I'm not sure how to refresh that. Okay, I apologize. But continue with the notes. For number 1, notice that I only have an x variable. I don't have a y here. So I want you to think about this as, well, my only approach would be to solve for x. That's the only thing I can do. So if we took a step forward, we notice that we would subtract the 3 from both sides. That would leave me with a negative 2x is equal to 4. All right, perfect. So we have negative 2x is equal to 4, and we know that we need to solve for x. So we're going to divide both sides by negative 2. When I divide both sides by negative 2, I get x is equal to negative 2. Now, anytime we graph lines, we need 2 points. So I'm going to make a note here. We need 2 points to graph a line. Okay, we need 2 points to graph a line. What this is telling us here, x is negative 2, is that in our 2 ordered pairs, x has to be negative 2. So the x coordinate in each ordered pair has to be negative 2. There's no other way. Remember, every ordered pair is x and then y. That's why it's ordered, alphabetical order. So my x's are negative 2. Now, the really great thing is you can choose any value here for y. So let's say I pick a 0 and I pick a 3, just because I felt like it. So we're going to plot the points in negative 2, 0, negative 2, 0, and negative 2, 3. Once I plot these 2 points, I'm going to take my straight edge, and I'm going to connect these. And voila, here we have it. Okay. We have a vertical line. We know it's going to be a vertical line simply because x is equal to negative 2. Notice that because it says x is equal to negative 2 and there's no mention of y in here, it would make sense that it only goes through the x-axis. Look at this line. You see how this vertical line only goes through the x-axis? That's perfect, right? That is perfect. And every ordered pair on this line, no matter where you are, x will always be negative 2. We're going to do the same thing for number 2. So for number 2, we have 1/7 y plus 1 is equal to 0. So we're going to take a step forward. We're going to subtract the 1 from both sides, and we have 1/7 y is equal to negative 1. So far, so good. We learned from Unit 2 that if we wanted to cancel fractions in an equation, we would multiply by the LCD. The LCD in this case is 7. So we're going to multiply every term by 7. Here's my first term. Here's my second term. So I'm going to multiply both terms by 7. We notice that the 7s are going to cancel, numerator for denominator, so we're dividing that out. And that leaves me with 1y is equal to negative 7. Same idea with number 1. We need 2 points to graph a line. So we are told that out of these 2 points, these 2 ordered pairs, y has to be negative 7. And it doesn't matter what x is. We just know that y has to be negative 7. So remember that every ordered pair is x then y, which means we have the freedom to choose any values for x. There are no restrictions on x. We're just told that y has to be negative 7. So why don't we use 0 and let's do 4, just because, again, just because I feel like it. So 0, negative 7, negative 1, 2, 3, 4, 5, 6, here's 0, negative 7, and then 4, negative 7, so 1, 2, 3, 4. Negative 7 is here, and then all we have to do is connect with a straight edge, or connect them with a line using a straight edge, and voila, we just graph the line y is equal to -7. Beautiful. Hopefully that clarifies how to graph horizontal and vertical lines. If ever you have an equation with just one of the variables, you'll know right away whether or not you're graphing a horizontal or a vertical line. Okay? Next, I would like us to move into slope. I would like us to learn a little bit more about slope of a line and what that means. So first off, slope, when we dissect slope, we have to think about slope being either rising over running or falling over running. So notice here I've put symbols above it. So I wanted to point out that if your slope were positive, you're going to rise before you run. If your slope is negative, you're going to fall before you run. In words, the slope is the change in y over the change in x. When we think about this logically in terms of this language here, change in y over change in x, visually, if we change in y, like as if in this graph, if we change in y, notice that we're changing in either the rise or the fall. So that has to be in the numerator. Change in y is rise or fall. And then when we change in x, we're running, correct? Do you see how that would make sense that you'd have the change of x in your denominator because your denominator of slope represents that run, okay? And we're always going to run from left to right. So when we read a graph, we move from left to right. Always we move from left to right. Okay. Next, we have the slope formula. So I would really like you to commit this to memory. We're going to use it a lot, so I'm sure that that won't be a problem whatsoever. We have the slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You will use this slope formula to help you calculate the slope between 2 points. Your first point is x1, y1, and your second point is x2, y2. Okay? Your points will always be ordered x then y, x then y. That'll never change. I have seen students write x1, x2, y1, y2, but that doesn't make sense because those are not ordered pairs. So you have to be very, very careful as you label your points. They're always going to be x1, y1, then x2, y2. If there was a third point, it'd be x3, y3, etc., etc. Okay? So we're going to use all of this information to help us calculate the slope between 2 points. Let's take a look. For number 1, it says plot the points in the graph provided, identify the slope graphically, and then prove it algebraically. So the first thing we're going to do is we are actually going to plot both of these points. So we have a -3, -6. I'm going to plot that first. In order to plot -3, -6, we're going to move left 3 units, 1, 2, 3, and down 6 units, 1, 2, 3, 4, 5, 6. There's a -3, -6. Next, we're going to plot the point 2, 5. So we're going to go over 2, 1, 2, and up 5. 1, 2, 3, 4, 5. So I would like you to do that carefully. Once you plot those 2 points, please connect them with a line. So I'm going to use my straight edge and connect these so it's easy to see. Beautiful. Okay, what I'd like us to do is first to identify the slope graphically. Now I'm going to write the slope formula down in terms of words. So notice here that as we read this graph from left to right, we hit the line and we go uphill. So remember, we're reading from left to right. So if I follow my pen and I simply move to the right, I hit the line and then I'm going to go uphill. So we know that our slope is rising, then running. It's not falling, we're rising, we're going uphill. So I'm going to write that the slope is rise over run. In order to calculate the slope graphically, we want to look at going from this point to this point. But first we must rise before we run. So let's think about this. From this point to this point, we're going to have to rise 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units. So we rose 11 units, and then we're going to run 1, 2, 3, 4, 5 units. So according to what I just counted, to move from the first point to the second point, I had to rise 11 units and then run 5 units. Perfect. Graphically, there's my slope. Now we're going to prove this algebraically. The variable that represents slope is m, and our slope formula is y2 minus y1 over x2 minus x1. It's always going to be helpful if you guys write down exactly what the formula is and then to make the substitutions. It's going to help a lot. Next, I want to identify what my x1, y1, and x2, y2 coordinates are. So I look at the two ordered pairs that I'm given, and I'm going to say, let's call this my first ordered pair, my second ordered pair. So if I call this my first ordered pair, this is going to be x1, y1. Since I'm calling this my second ordered pair, this is going to be x2, y2. What this means is that the value of x1 is -3. The value of y1 is -6. The value of x2 is 2. And the value of y2 is 5. Now let's plug into our formula. Notice how I wrote the fraction bar and I put the minus symbols in here because they need to stay. They need to actually stay in the formula. We're just going to substitute the values. Y2 in this case is a +5. Y1 in this case is -6. X2 in this case is a +2. X1 in this case is -3. Notice how I use parentheses. I write the -6 inside parentheses because we already have a negative here, a minus, and we want to note what ends up happening to this sign. So if this is 5 minus a -6, essentially that's the same as 5 plus 6. 5 plus 6 is 11. And then 2 minus a -3, that's going to be the same as 2 plus 3, which is 5. So check it out, guys. We counted the rise over the run to identify what the slope is, which is 11 over 5, and then we proved it algebraically by using the slope formula, showing that yes, it is 11 over 5, and we in fact did this perfectly. Okay, we're going to do this again. So let's look at number 2. For number 2, we're going to plot these 2 points, -4, 2 and -4, -5. So I'm hoping that you guys are staying right on track with me. So -4, 2, we're going to plot that first. -1, 2, 3, 4, -4, 2. There's my first point. Then we have -4, -5. So -4, -5. 1, 2, 3, 4, 5. Next, connect with a straight edge. Perfect. Recall that slope is rise or fall over run. Because this is vertical, I'm going to say let's start at this point and rise to get to our next point. If we want to calculate the slope graphically, let's take a look at what's happening here. When I hit this line, I can rise. I can rise 1, 2, 3, 4, 5, 6, 7. So I can rise 7 units. But as I move from this point to this point, did I have to run at all? No, absolutely not. I rose 7 units, but I did not have to run in order to get to that point. So there's a 0 run. If you took your calculators and you punched in 7 divided by 0, look what you would get. You would get error. Recall that when we take a number and we divide it by 0, we know that that is undefined. Okay? The slope of every vertical line will always be undefined. So I'm going to make a note of that. Even though we'll see that on the next page written down, I think it would be a great spot to jot down the fact that every vertical line has undefined slope. Okay, that's really, really important. Every vertical line has undefined slope. Now let's do this algebraically. M is equal to, let's go ahead and write down the formula once again. Y2 minus Y1 over X2 minus X1. What I would urge you to do is label your ordered pairs. You have X1, Y1, and you have X2, Y2. I would always urge you to label your ordered pairs. That way you can use that information and plug it right into your equation without having any mistakes. Having things labeled, it makes it just so much clearer. Okay, Y2 in this case is -5 minus Y1 in this case is a +2. Perfect. X2 in this case is -4 minus X1 in this case is also a -4. You see how we make the substitution for each value? And when we had that -4 here, we wrote it in parentheses so that way we didn't lose the sign. So now we have a -5 minus 2, so that gives me -7. And a -4 minus -4, so -4 plus 4 is 0. So in which case, we figured out yet again that the slope is undefined. Okay? Our slope is undefined. So we've figured this out simply by counting, that's graphically, and then again algebraically by using our slope formula. Okay, what I'd like you guys to do is take a moment to try number 3. I would like you to plot both points, and I would like you to identify the slope graphically and then prove it using the slope formula. So I'm going to give you a couple minutes to do this, and I am going to attempt to fix the chat. Okay? Okay, very cool. So welcome back. We are going to plot both of these 2 points. We have -3, -1. So -1, 2, 3, -1, that's right here. And then 3, -3, so we're going to go 1, 2, 3, -1, 2, 3. We're going to connect these with a straight edge. And you guys are sending in the slope, and that is awesome. You guys are getting -1/3, which is fantastic. So I want to show you exactly how we get that. Now, in this case, we notice that when we hit this line, we're moving downhill. Very nice, guys. Excellent. So when we hit the line, we're moving downhill. So we're no longer rising, then running. We are falling, then running. So slope in this case is going to be a fall before we run. Recall, we always run to the right, never run backwards. Okay? So let's see. If we're going to move from our first point to our second point, we're going to end up falling 1, 2 units, and we're going to run 1, 2, 3, 4, 5, 6. So we fell 2 units and we ran 6. Anytime we have a fraction that can be reduced, we must reduce it. So the slope is actually -1/3. So nice job, guys. Nice job for all of those -1/3 submissions. Interestingly enough, I want to show you what this looks like on the graph itself. If we have a slope of -1/3, that means we fall 1 and run 3. Check it out. If I start at my original point and I fall 1 and run 3, I've just found another point on that line. I'll do it again. Fall 1, run 3. Bam. I'm now at the next point that I was given. I'm going to fall 1 and run 3. I just found yet another point on this line. So by applying the slope, we can literally find an infinite number of points on that line. Very cool. Now we're going to calculate this algebraically. Y2 minus y1 over x2 minus x1. I told you, you're going to end up committing this to memory just by rewriting it again and again and again. Let's call our first ordered pair x1, y1, and our second ordered pair x2, y2. So y2 is a -3 minus, y1 is a -1, so remember we're going to use parentheses. x2 is a +3, and x1 is a -3. -3 minus a -1 is the same as a -3 plus 1, which is -2. And then 3 minus a -3, or 3 plus 3, is 6. And same thing, we reduce. So our slope is a -1 over 3. We fall 1 and then run 3. Awesome job, guys. Very awesome. Let's turn the page and continue with this idea. We're going to do the exact same thing for number 4. We have 0, -5, and 6, -5. So I'm going to move a little quicker through this. Let's call this x1, y1, x2, y2. 0, -5, 1, 2, 3, 4, 5. And then 6, -5, 1, 2, 3, 4, 5, 6. -5 is right here. And then we're going to connect these with a straight edge. Okay, bam, there's my line. While we do this, guys, what's the equation of that line? What is the equation of this line? Go ahead and send that into the chat while we continue. Taking a look at this line, we can still say that slope is rise over run because we're neither rising nor falling, and I think that's kind of the point. So as we go from our first ordered pair to our next ordered pair, we didn't rise at all. There was no rising to get from here to here. So we're going to call that a 0 rise. And then notice that to get from this point to this point, Hyder, you're close. Think about this carefully. Yes, excellent, Brittany. Excellent. That's perfect. So in order to get from one point to the next, we had to run, and we ran 6. Regardless of what happens, if you took your calculators and you punched in 0 divided by 6, you would get 0. So the slope of this line is 0. Now we're going to calculate slope algebraically. M is equal to y2 minus y1 over x2 minus x1. y2 in this case is -5. Minus y1 is -5 over x2, which is 6, minus x1, which is 0. If we do the math, we find this is -5 plus 5, which is 0, because they're additive inverses of each other. They're opposites. 6 minus 0 is 6, and voila. Algebraically, we also found that the slope is 0. Now, just a little bit ago, I asked you to give me the equation of this line. The easiest way to do that is to look at the ordered pairs. Notice that in both of these ordered pairs, they have a -5 in the y position. So -5 is y, or in other words, that is the equation of the line. Y is equal to -5. Nice job, Brittany. That was excellent. I'm going to go back one page for a moment. Okay. For this equation, or for this line here, number 2, let's look at the ordered pairs. Notice that they both have a -4 in the x position, which means that the equation of this line must then be x is equal to -4. okay? In just a little bit, once we start learning about slope-intercept form, we'll be able to write the equations of all of these lines as well, okay? So for right now, we know the equation of a vertical line, and we also know the equation of a horizontal line. All right, beautiful. Let's fill in these notes. The slope of every vertical line is undefined. An example of that is x is equal to 2. If we graphed x is equal to 2, that would be a vertical line. It would go through the point 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, right? Or 2, negative 1, 2, negative 2, 2, negative 3, etc. It would be a vertical line that goes strictly through the x-axis. That line has a slope that is undefined. Good. The slope of every horizontal line is 0. So when we have the example y is equal to negative 4, in this case y is equal to negative 5, it's nice and flat. So essentially there is no rise, only run. So it's a slope of 0 as you move from one point to the other. All right. Hopefully that is super helpful. The last piece of information regarding slopes for Unit 4 deals with parallel and perpendicular lines. So let's take a look. Here's an example of two parallel lines. I want you to notice that they both have a negative slope. They both have negative slope here. Okay. I want you to also notice that they're completely parallel, which means they will never intersect. So these two lines are completely parallel. So let's just say for a moment that our first point or our first line has a slope of, let's see, I'm going to say that this looks pretty awesome. And then I'm going to say that let's do, it's not perfect on this line, but let's just say that this is perfect. It's not exact, but no big deal. So then that means this is also perfect. So down 1 over 1, let's say that this has a slope of negative 1. If our lines are truly parallel and our first line, line 1, has a slope that's a negative 1, our line 2 has to have the exact same slope. So it also has to be negative 1. The slopes of parallel lines are identical. They are exactly the same. There's no change whatsoever. When you look at perpendicular lines, visually, they cross at exactly a 90-degree angle. Do you see it? It's a perfect 90-degree angle. I want you to notice that if I call this line 1, you see how we're going downhill? So my slope is negative. If you look at line 2, notice we're going uphill. So that's one of the key features. That when you have lines that are perpendicular, their slopes are opposite, meaning opposite signs. So opposite sign. And they're reciprocal. So there's two things going on here. You have to take the opposite reciprocal of the slope. So for instance, let's say that my slope here was, and I'm just going to make this up, let's say it's a negative 1 over 3. Okay? If my line 1 has a slope that is a negative 1 over 3, then line 2 has a slope that is positive 3 over 1, or simply 3. This is how you know two lines are perpendicular, okay? Their slopes will be negative reciprocals of each other. One's positive, one's negative, and they're going to be reciprocals. Consider that 3 over 1 is the same as 3, so you can record that your slope is 3, and it's the line perpendicular will have a slope of negative 1 over 3. Just for your point of reference, parallel lines have a symbol that looks like this. It looks like it's an 11, but it's not an 11. It's just two vertical bars. And the symbol for perpendicular is simply an upside down capital T. All right. On that note, let's turn the page and fill in a chart with this idea of parallel and perpendicular. Awesome. In the chart below, identify the slopes of lines that are parallel and then that are perpendicular to the line with a slope identified in your first column. So all that means is if my original line has a slope of 2/7, then a line that is parallel to that line has the same slope. It has to be because they're parallel. So if my line has a slope of 2/7 and my next line is perpendicular, then it's going to have the opposite sign reciprocal of that slope. So the slope of my perpendicular line will be not a positive, but a negative, and not a 2/7, but a 7/2. Okay, what I'd like you guys to do is take a couple minutes and fill in the entire chart. All right, let's take a moment and see what you guys get. So for a line that has a slope of -4/5, a line that's parallel will also have the same slope. So what I'm going to do is I'm actually going to fill in the column for parallel lines. If your line has a slope that's 8, the parallel line will have a slope that's 8. If your line has a slope that's a -2, the parallel line will have a slope that's a -2. If your line has a slope of 0, so will your parallel line, and then same thing with your line that has a slope that's undefined. Okay, now let's take care of the perpendicular lines. For our slope of -4/5, if we have a line that's perpendicular to the line with a slope of -4/5, your slope is positive 5/4. If your line has a slope that's +8, a line that's perpendicular will be -1/8. Recall that you have to negate it and you have to flip it. Opposite sign and reciprocal. Two things, two pieces of information that you have to do, that you have to apply to that slope. If your line has a slope that's a -2, negate it and flip it, so it becomes positive 1/2. Now here's the interesting point. If we have a line that has a slope of 0, it's horizontal, isn't it? So if a line is perpendicular to that, doesn't it cross like so, vertically? And every vertical line has a slope that is undefined. So when we fill this in, that should have been undefined. Similarly, if we have a line that has a slope that's undefined, that's vertical. A line that's perpendicular will be perfectly horizontal, which means the slope of this horizontal line is 0. And that's what the chart looks like when it's all filled in. Excellent. Hopefully that made sense in terms of how you identify the slopes of a parallel and a perpendicular line. You simply have to recall those two bits of information, that parallel lines have the same slope, and then perpendicular lines have two things going on: opposite sign and reciprocal. Or in other words, you flip that value, you flip the fraction. All right. Let's learn our final technique for graphing lines, and that is graphing by using the slope-intercept form. I have a feeling that you guys are going to love graphing using this technique. I always use this technique if I'm graphing lines. I find it to be incredibly straightforward. And we're going to end up using this for when we move into Unit 5, when we graph systems of equations. So this is going to be incredibly handy, and I urge you to play around with slope-intercept form and make yourself super comfortable with this, okay? First things first, slope-intercept form is y is equal to mx plus b, where the m, just the m, is our slope, And this B term represents our y-intercept. Recall that in order to be a y-intercept, you have to be on the y-axis. So any point that's on the y-axis is always going to be 0 and then some sort of number. So the y-intercept in this case is 0, comma, whatever that value is. So let's play around with this. We want to identify the slope and the y-intercept in each of these equations. We're going to start with this first one. If it's helpful to you, directly above this, I'm going to write y is equal to mx plus b so that we can see the direct relationship between each of the variables. Notice here that the m is 8 and our b is 4. So if we want the slope and the y-intercept, we're simply going to use the definition. The slope for our first equation is going to be 8. You can write this as a fraction, 8 over 1, because it's helpful to note that slope is always rise over run or fall over run, obviously depending on whether it's positive or negative. So in this case, because my slope is 8 over 1, this means I am rising 8 and I'm running 1. And we'll see how that is applied when we actually graph lines using slope-intercept form. Next, I want to identify my y-intercept. The b term, so the constant term in our equation, represents the y-intercept. And in this case, our y-intercept is 4. Okay, so it's 0, comma 4. I want you to then think about this logically. Out of the slope and the y-intercept, only the y-intercept is a point on the graph. Slope is just movement, how you move from one point to the next. The y-intercept is an actual point. So I want you to think about this as logically, 0, 4 would have to be our starting point, and then we would apply the slope. Let's do number 2 before we see slope-intercept form in action in terms of graphing. My slope for number 2 is going to be right here. Here's my slope. This is my m. So slope is negative 2 over 1 in this case. We can always write it as a fraction like I said before. So consider, because we have a negative 2 over 1, we want to note that this means we're going to fall 2 and run 1. Recall that whenever we run, we always run to the right, never run backwards. Hyder asked a really great question. If on the test you wrote that the y-intercept is simply equal to 4, that would be wrong because you want to make sure that you write it as an ordered pair. An ordered pair tells me as your instructor, and actually anyone else who looks at your work, it tells that individual that you know that the y-intercept is an ordered pair. So you always want to write it as an ordered pair. So for instance, for number 2, if we were going to write our y-intercept, we're going to write it as an ordered pair, 0, comma, and then notice that negative 4/5 is b. That is my constant term. So we're going to write that as my y-intercept. Now with something like this, it's a little bit harder to graph, right? How do you graph negative 0.8? You get really, really close to a negative 1. I mean, otherwise you would use like some sort of mathematical software. But luckily for us in this class, I won't ask you to graph things like that, okay? I'll ask you to graph values that are much more manageable. Let's turn the page and see this in action. All right, number 1. We see here that y is equal to 3/7 x minus 2. If we think of the same thing, y is equal to mx plus b, we notice that m is 3 over 7, and m represents slope. So the slope, which is m, is 3 over 7. What this implies is that we're going to rise 3 because it's positive and then run 7. We always run to the right. Next, I want to write the y-intercept, and we know that's going to be 0, comma, and then in this case, our b is a -2. So my y-intercept is 0, -2. Whenever we graph by using the slope and the y-intercept, we always plot the y-intercept first, and then we apply the slope from that point. Okay? We plot the y-intercept first, and then we apply the slope from that point. So our y-intercept in this case is 0, -2. So 0, -1, -2, 0, -2. There's my first point. Because our slope is 3/7, that means you rise 3 units, and then you run 7 units. So from my starting point right here, we're going to rise 3 units, 1. Sorry about that. You know, puppies in the house. So we are going to, from this point, we're going to rise 3 units. So 1, 2, 3. Oops, sorry, I didn't mean to put a point there. We're going to rise 1, 2, 3, and then run 1, 2, 3, 4, 5, 6, 7. So there's my second point. Again, I didn't mean to mark that. So you rise 3, you run 7, and then connect it with a straight edge. See if I could do this all nice and neat. Beautiful. And voila, you have your line. It's literally as straightforward as that. Make sure your equation is in slope-intercept form. So we're going to make sure that the line is in slope-intercept form, and then state what the slope is, state what the y-intercept is, and then just plot the y-intercept first, then apply the slope. Okay, let's take a look at number 2. 2x plus 4y is equal to -16. I want you to notice here that this is definitely not in slope-intercept form. So, Hyder, you asked about one more point on this line. If you really wanted to identify a point that was to the left, so normally we would rise 3 and then run 7. If you wanted to find a point here, you'd fall 3 and run back 7, okay? But I want you to be careful with that. Make sure that you're understanding that no matter what, to move from one point to the next, we read from left to right, you're going to rise 3 and run 7. So if we wanted to, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, there's another point on the line, and we can test it. So from here, we can go up 1, 2, 3 and run 1, 2, 3, 4, 5, 6, 7. Bam, we found our next point. Up 3 over 7, we found our next point. So yes, Hyder, you're totally correct. Just be careful as you do this. So for number 2, 2x plus 4y is equal to -16. We want to rewrite in slope-intercept form. So again, the goal is y equals mx plus b. That is the goal. So what you'll want to do is isolate y. Recall that we have two terms, a 2x and a 4y. We want to isolate our second term because that's the one with y. So we want to move the 2x. In order to move the 2x, we're going to have to do the opposite operation, which is to subtract it. Recall that when we want to move terms from one side of the equation to the other, we use the opposite operation, and you can only add or subtract terms to move them completely. So these are going to cancel, and that leaves us with 4y is equal to, and instead of writing -16 minus 2x, we want this in descending order. So we want the -2x to come first, then -16. Next, we want y to be completely on its own. So we're going to divide every term by 4. We learned that one of the rules of solving linear equations is that if we wanted to multiply or divide, we have to do that to every single term in the equation. We do not get to pick and choose. So we divide every term by 4 so that we're left with y by itself. Negative 2 over 4 reduces. Please always reduce. We're going to divide each by 2. That leaves me with negative 1 over 2x. And then negative 16 divided by 4 is negative 4. So on that note, let's identify the slope. The slope is negative 1/2, right? Y equals mx plus b. And the y-intercept in this case is 0, negative 4. Perfect. According to what we did for our last problem, we notice that the only thing we could plot is the y-intercept. So we're going to start with 0, negative 4. So 0, negative 1, 2, 3, 4. Start with 0, negative 4. And now we're going to apply the slope. Because we have a negative slope, that means we're going to fall 1 and run 2. So from this point, what we plotted, we're going to fall 1 unit and run 2. 1, 2. Let's do it again, just for good measure. Fall 1, run 2. How about another one? Fall 1, run 2. And we can continue to do this so that we can identify several points on the line. Once you have several points on the line, go ahead and connect it. Oh no, my line's going to look a little weird. That's okay. No big deal. Perfect. What I'd like you guys to do is use the same strategy to graph problem number 3. So I'm going to give you about 2 minutes to rewrite this in slope-intercept form, and then using the slope and the y-intercept, graphing it on your coordinate axes. Okay? Okay, so let's take a look and see how you guys did. So we had a couple submissions in terms of answers, so thank you, Brittany. Let's take a look and see what we have here. We want to rewrite the equation in slope-intercept form. That's the key fact here. We started with standard form, so we need to manipulate this equation. So we're going to begin by adding 8x to both sides. That leaves me with 4y is equal to, instead of putting negative 12 plus 8x, let's put the 8x first and then negative 12 after. Next, we're going to divide each term by 4. That leaves us with y is equal to 2x minus 3. So if you said that the slope was 2 over 1 and that the y-intercept was 0, negative 3, then you are perfectly correct. So excellent job. Excellent job, Brittany and Christina. Nicely done. So now we're going to plot the point 0, negative 3. So 0, negative 1, 2, 3. And then we're going to apply the slope. Recall that because this is positive, we want to rise 2 and run 1. So from here, we're going to rise 2, 1, 2, and run 1. Let's do it again. Rise 2, run 1. Let's do it one more time. Rise 2, run 1. Notice we found 4 points on that line. We only need 2 to make a line, but why not? It helps to make this really perfect. Hopefully I can get this. Yay! Not bad. And there you have it. That's all you have to do to graph a line using slope-intercept form. Hopefully you can get the sense that I really like using this technique because it's a lot quicker than graphing by plotting points. I will tell you that you should still know how to find your x-intercept and y-intercept because you'll have questions that ask specifically for those two things. So for instance, let's look at this line. By looking at this line, we know the y-intercept is 0, negative 3. We found it. We know how to identify that information from slope-intercept form. But if we look at this line carefully and closely, you see that the x-intercept kind of looks like maybe it's 1.5 comma 0. But we can't possibly be totally sure just by looking at this graph. I mean, we can guess that it definitely is 1.5 comma 0, but we still have to consider, in order to prove that, we can show that algebraically. So as a recap, if we wanted the X-intercept, remember that y has to be 0. So what I'm going to do is I'm going to take this y of 0 and I'm actually going to plug it into the original equation. So check this out. Negative 8x plus 4 times 0 is equal to negative 12. 4 times 0 goes away, so we have negative 8x is equal to negative 12. And if I divide both sides by negative 8, notice I get x is equal to, and by the way, these are positive. If we divide both the numerator and denominator, for instance, by 4, then we get 3 over 2, which is the same as 1.5. So the X-intercept is exactly what we thought it was, 1.5 comma 0. And here's the proof. We plugged in a 0 for y, we calculated x, and therefore we found the X-intercept. This was the process we used in our last class, so Tuesday, to figure out the X-intercept. Same thing with the Y-intercept, except now we know a new technique, which is if we write the equation in slope-intercept form, our term that's the b term is our Y-intercept. And I hope you guys can see that that's definitely always going to be the case, because if we made x 0, 2 times 0, that's just 0, and 0 minus 3 is a negative 3, so y is negative 3. Bam! Our Y-intercept. So we can prove that algebraically as well. Let's go ahead and turn the page for possibly one more problem. Okay. For our first equation, we have 4x minus 5y is equal to 20. What I wanted to do is I wanted to combine all the things that we just learned. I wanted us to identify the slope. I wanted us to identify the x and the y-intercepts. I wanted us to graph the line. And then I wanted us to identify the slope of a line that is parallel and then perpendicular. So essentially, like I said, this combines everything that we've been learning thus far. So let's take a look. We have many different approaches for problems like this. I want you guys to notice that number 1 is in standard form. Because number 1 is in standard form, we could go right into calculating the x and the y-intercepts, because I find that calculating the x and the y-intercepts for an equation in standard form tends to be really, really nice. So if it's okay with you, I'm actually going to start by finding the x and the y-intercepts. To find the x-intercept, we know that we want to make y 0. So we have 4x minus 5 times 0 is equal to 20. This term goes away, so we're left with 4x is equal to 20. If you divide both sides by 4, you get that x is 5. So my x-intercept is 5, 0. Let's go ahead and plot that, 5, 0. 1, 2, 3, 4, 5. Here's 5, 0. I'm going to do the same idea, but this time I'm going to calculate the y-intercept. With the y-intercept, we know that x has to be 0. So let's plug it in and see what it looks like. 4 times 0 minus 5y is equal to 20. Recall that 4 times 0 is 0, so 0 minus 5y is simply negative 5y. And then we're going to solve for y by dividing both sides by negative 5. 20 divided by negative 5 is negative 4. So my y-intercept is 0, negative 4. So let's plot that. 0, negative 4, negative 1, 2, 3, 4. I would like to connect these two dots with a line using my straight edge. Perfect. And now what I'm actually able to do in this case is I can calculate slope graphically. I can note first off that as we read this graph from left to right, we know that we are going uphill. So as we read it from left to right, we're going uphill. So we know that our slope is positive. So as we go from our first point to our second point, because we're rising then running, remember, I'm going to write that down. Slope is rise over run. Again, in this case, because we're going uphill, we are going to rise 1, 2, 3, 4, and run 1, 2, 3, 4, 5. We rose 4, and we ran 5. So we just found the slope. That takes care of A and B for this problem. The slope is 4 over 5. The x-intercept is 5, 0. The y-intercept is 0, negative 4. We've graphed the line, so that takes care of part C. And now we want to identify the slope of a line that's parallel and then a slope of a line that's perpendicular. So let's recall what it means to have two lines that are parallel. If two lines are parallel, they have the exact same slope. The slope of this line is 4 over 5. So if another line is parallel, it will also have a slope 4 over 5. If we have a line that is perpendicular, its slope would be the opposite reciprocal. So you're going to negate it and flip it. So because our slope was positive, our new slope is going to be negative, and our original slope was 4 over 5, so the line that's perpendicular will have a slope of negative 5/4. And that takes care of everything that we just learned. All of those pieces connected together in one equation. I would like you guys to finish off class by taking care of number 2. Number 2 is y minus 5 is equal to negative 3/4 x. I would like you to work through this problem and see if you can identify the slope, identify the x and the y-intercepts. You may have to calculate it. You may have to actually use the technique we use here by plugging in zeros. You'll graph the line, and then you'll identify the slope of a line that's parallel and perpendicular. All right, guys, I believe that's it. If you have any questions, email me. But besides that, please stay safe, please stay healthy, and I will see you guys next Tuesday. Nice job today.